Question 5, page 34. It's about a car that travels a distance of s meters, and we have to show that with a maximum acceleration of a maximum deceleration of b, and a maximum velocity of v, a speed limit of v, and we have to show that time is equal to this here, v over 2a plus v over 2b. Our time is equal to all along here, so this straight line is going to give all of our time. Because v is equal to u plus at, we get v is equal to at, and we get, because u is equal to 0, and we get t is equal to v divided by a, which is what we have here. I'll just rub this out because we don't need it for much. On the far side over here, we have a similar situation. V is equal to u, the same formula, plus at. In this case, v is equal to 0 because we're looking at down here. The velocity, final velocity, is 0 because he ends at rest. U is equal to v, and our acceleration is plus, and it's minus b because it's deceleration by t. So this gives us the same result. It gives us that our time is equal to v divided by b. So I suppose the point in saying this is that you don't necessarily have to worry too much about this, the changing of the u's and the v's in the formula. You're going to get the same structure of result, v over a, v over b. Okay, that leaves us trying to find this time here for b. And there's no formula that we can do that. If you try to use v is equal to u plus at, u is equal to v. So you're going to get, if you try to use to get your time for this, you're going to get v is equal to u plus an acceleration of 0. So you get v is equal to u. You don't get any time in here. And the same with the other velocity formula. V squared is equal to u squared plus 2as. We don't have an s at this stage. We acceleration is 0 over here in this point. So we just have v squared is equal to u squared. So that's not going to help us. So what we need to do is we need to get the distance. And if we can get the distance, we know that the distance that they covered in the trip was s. We can work out the distance of this and this. If we work out the distance of b, and we divide the distance by v, it gives us your time. Okay, because this is a rectangle. This is the area, which will be the distance we're covering in b. And if we divide it by v, it gives us the time here. So the area of this is going to be pretty easy. That's going to be, the area of a is going to be half the base by the height. So it's going to be v over a, v over 2a, multiplied by the height is going to give me v by v. So that's going to give me v squared over 2a for this bit. That's my area there. Similarly, the area for c is going to give me half the base by the height, which is going to give me v squared over 2b. Okay, so let's continue this on the next page. Now, if a is equal to v squared over 2a and b is equal to v squared over 2b, that should be c is equal to v squared over 2b. Well, then what's b equal to? Well, b is going to be equal to s, which is the entire distance, minus v squared over 2a minus v squared over 2b. Okay, so that's the area of b is equal to all of this here. And then the time is going to be this divided by b. Okay, so the time here is going to be this divided by v. So the time for b, so we'll say tb, time of b, is equal to s minus v squared over 2a minus v squared over 2b, all divided by v. Okay, so that's going to give me, I'll do this in a different color. So that's going to give me s divided by v, that's this v here, goes to s divided by b, minus, now I'm going to have v squared over 2av, and one of these cancel each other out. Okay, so this squared cancelled out with this v, so I left with v over 2a, and I'm going to have minus v over 2b, which is, I think, what we're asked to show. So that's it, QED, and that's done. Okay, you'd obviously tidy it up a little bit, don't leave it messy like this, but that's it. Okay, let's move on to the next bit. As a quick aside, for looking at ratios of things, if we're looking at these two areas here, for example, this is an area of 3 and this is an area of 2, the ratio of this one here to the whole lot is equal to 3 divided by 3 plus 2. So it's 3 over 5, and equally this is equal to 2 over 3 plus 2. Okay, let's go back to have a look at the question, see what it's looking for. So the second part was said, it wants to know, can you express the time like this here, the square root of 2s multiplied by a plus b over ab. In this case, there's no speed limit. We still cover an area of s, but we have to show the time is equal to this. Because there's no speed limit, you know, the car just keeps accelerating until it gets as fast as possibly can, and then it accelerates. Well, not as fast as possibly can until it can decelerate as quickly as it can at b, and it's going to cover the distance s in that shortest time. So it accelerates really quickly up to some maximum speed in order so that when it decelerates, it covers the distance of s. So that's why there's no line across the top. The ratio of 1 to 2, so we're talking about now ratios. So the ratio of T1 to T2 is the same ratio as B is to A. Okay, we discussed this before. Obviously, as you can see, B is a bigger acceleration, a bigger deceleration, a bigger magnitude, and it's related to the time here, and that they're related. And equally, A is a slower acceleration than B, and so it's related to the time here. So T1 is related to T2 is related to the ratio of B to A. And like we showed before, that's going to give us the same ratio as B over A plus B is the ratio of A over A plus B. Now there are the ratios. So the actual time for T1 is BT over A plus B. And the actual times for T1, and the time for T2 is going to be AT over A plus B, and that's T2. Now the strategy is get the velocity, like the final velocity up here, the max velocity is equal to u plus AT. We have u is equal to 0, but A is equal to A and T is equal to one of these, like T1. That will get us this velocity up here. And then we're going to plug this particular velocity into S. So S is the distance that's covered, is equal to half. Well, the base is equal to T, the whole base is T, because this whole area here is S, and the base is equal to T, so it's half of T multiplied by the height, which is this velocity we just worked out. So let's do that. Okay, so V is equal to U plus AT, well, U is 0, A is equal to A. Let's go back and see what T was. Well, T was equal to BT over A plus B. BT over A plus B. BT over A plus B. And that's equal to ABT over A plus B. Okay, so that's our velocity. So we had this function like this. We now have our velocity here. We have A here, we have B, and we have T1, T2, and the whole thing was T. So now we want to work out S. So S is equal to half the base by the height, which is equal to half of T, and the height is equal to ABT over A plus B. Okay, and that's going to give us ABT squared over 2A plus B. Okay, and I'll just, S is equal to that. So we're looking for T, the time. So time is equal to, I multiply S by 2AB, A plus B, and then I divide it by AB. Okay, so there's my AB here. I've just divided it by that, and I multiplied S by 2AB, gets this up to the top, divided then by AB, and then I get the square root of it all. So it's equal to square root of 2S into A plus B, all divided by AB. Which is what we're asked to do. So that's proven as well. That's fine. I think it goes without saying that the difficulty in this particular question is when you're asked something like this to prove is where do you start, you know, and I suppose you might start by thinking, well, I need to express things in A's and B's. We have acceleration A's and B's. You now have this technique where you can express the time as a ratio of the accelerations A's and B's. Note that the distance is also divided into the same ratio, exactly the same ratio as t1 and t2. So the distance is related to the accelerations as well. Okay, I hope that helps.